All right, guys, so let's take a look at a few more ellipses. All right, so example 3, we again want to analyze and graph the equation. So we have x squared plus 9y squared plus 6x minus 18y plus 9 is equal to 0. So the first thing you'll notice about this equation is that it's not really in the correct format, right? We want our ellipses to be in the standard form that I showed you before, where we have the x minus 8 squared over a squared or b squared, y minus k squared over a squared or b squared is equal to 1. So in order to take the equation that we're given and put it in that standard form, we are once again going to have to complete the square, okay? So in order to complete the square, we're going to want to start by rearranging the equation. So we're going to group our x terms together, we're going to group our y terms together, and we're going to move any constant terms over to the other side just to get them out of the way. So I'm going to start by rearranging here. So x squared plus 6x plus 9y squared minus 18y is equal to negative 9. So again, group our x's, group our y's, move the constant over to the other side, okay? All right, now the other thing to remember with completing the square is we always want to think about what number do we need to add in order to make this a perfect square trinomial. But if you look at our y terms on this one, we haven't quite dealt with a situation like this before where our y squared has a coefficient in front of it. So before we can complete the square, we have to pull out the GCF from our x terms and we have to pull out the GCF from our y terms. Now there is no coefficient in front of the x squared term, so there's nothing to worry about there. So we'll just have to think about what do we need to add to our x's to complete the square. But with the y's, we have to start by pulling the 9 out before we complete the square. Okay, again, you have to pull out the GCF before you complete the square. Okay, all right, so if we pull that 9 out of both of our y terms, we'll have a y squared minus 2y. Okay, we'll have to figure out what to add there to make this a perfect square trinomial. Okay, and of course, always remember that whatever you add to one side, you have to add to the other side as well. Okay, so let's start with our x's. This is going to be the easy one. So to complete the square, we take our b term, which is a 6, divide it by 2. So 6 divided by 2 is 3, and then 3 squared gives us 9. I'm going to add a 9 to the left to complete the square on our x's, which means I have to add a 9 to the right as well to keep the equation balanced. Okay. All right, now let's work on our y's. So we have a negative 2y. So again, negative 2 divided by 2 is a negative 1. Negative 1 squared is a positive 1. Okay. All right, now here's where we have to be a little bit careful. When we're thinking about adding something to the other side, we have to remember that this 1 is inside a set of parentheses that's multiplied by a 9 out front. So really, we didn't just add a 1 to the left-hand side of our equation, we added 9 times 1 to the left-hand side of our equation, which means we also need to add a 9 to the right-hand side of the equation to keep this properly balanced, okay? So if you have to factor out a GCF before you complete the square, remember to multiply that GCF by whatever number you added on the left-hand side and add that to the right-hand side when you're balancing your equation. Okay, so then we're going to go ahead and simplify. So factor our x's and our y's. This is going to give us x plus 3 quantity squared plus 9 times the quantity y minus 1 squared. And then negative 9 plus 9 plus 9 is going to equal 9. Okay, so this is starting to look a little bit closer to what we want. We at least have the factors in this. But keep in mind, the standard form for these equation of ellipses is always equal to 1, okay? Right now, we have an equation that's equal to 9. So in order to make this equal to 1, we need to divide everything through by 9, okay? And the reason I'm choosing 9 is because that's what our equation is equal to. That's our constant term. So I need to divide that out in order to get a 1 on the right-hand side. Okay, so now to simplify, this is going to become x plus 3 quantity squared divided by 9. In that middle term, the 9's cancel. So we'll have y minus 1 quantity squared. So I'm going to leave it over the understood 1 because we'll want to think about that when we're choosing our a's and b's in a second. And that's now equal to 1. Okay, so if your equation is all expanded out, the first thing you have to do is start by completing the square. And once we complete the square, then you can go ahead and find all of the pieces that you need. Okay, okay, so let's go ahead and go through the process of graphing this one. So to start with, we need to identify our a and b. In this case, 9 is bigger than 1, so the 9 is going to give us our a, and the square root of 9 is 3. The 1 is going to give us our b, the square root of 1 is 1. So with the bigger number under the x, we know our major axis is horizontal. All right, and the center, which comes from the h and k values, so with our x plus 3 and our y minus 1, the center will be at negative 3, 1. All right, let's go ahead and start graphing this. So the center is at negative 3, 1. Our major axis is horizontal, which means our minor axis is vertical. Okay, so major is horizontal, minor is vertical. Okay, next from our a value, we can find the vertices. Those are going to be to the left and right of the center because our major axis is horizontal. So 3 units left and 3 units right is going to give us our vertices at negative 6, 1 and 0, 1. From the b value, we'll find the points on the minor axis. Those are going to be up and down from the center along our minor axis. So 1 up, 1 down. We'll get our points on the minor axis at negative 3, 2 and negative 3, negative 1. Oops, nope, it's a lie. Sorry, I counted wrong. Negative 3, 0. Sorry about that. There we go. Okay. So then the last thing we need is our C value, which will help us find the foci. So for that, we'll use our B squared is equal to A squared minus C squared. Plug in our A squared and B squared. So 1 is equal to 9 minus C squared. So C is going to be the square root of 8, or 2 root 2, which is approximately 2.8. All right, so that's going to give us our foci. So that's going to tell us that from the center along the major axis, so to the left and the right, we're going out 2.8 units on either side. So 2.8 to the right, 2.8 to the left, and that gives us our foci. Okay, so 2.8 to the left of our center is going to be at negative 5.8 and 1. And then to the right, that brings us to negative 0.2 and 1. Lastly, just connect your points and you're good to go. Okay. All right, let's take a look at example 4. I'm not going to go through this whole example, but I at least want to go through the part of completing the square with you and putting this in standard form. And then I'll leave the whole process of graphing it for you guys to try on your own. Okay. All right, so again, analyze and graph. We have an equation that's fully expanded. So our first step is to put it in standard form. So we're going to rearrange, group our x's, group our y's, move the constant over to the other side. So I'm going to get 9x squared plus 4y squared. Oops, rearranging. I forgot what I was doing. 9x squared minus 54x plus 4y squared plus 40y is equal to negative 37. Okay, so start by just rearranging it. Okay. All right, now remember what I told you guys on the last example. Before you complete the square, you have to pull the GCF out of your x's and you have to pull the GCF out of your y's. So with our x's, I'm going to start by pulling out a 9. That would leave us an x squared minus 6x and then plus whatever we need to add to complete the square. With our y's, I'm going to pull out a 4. That's going to leave us y squared plus 10y plus whatever we need to add to complete the square. And that's still equal to negative 37. And then again, whatever we add to the left, we have to add to the right to keep everything balanced. Okay, now let's go ahead and complete the square. So starting with our x's, our b is a negative 6. So cut that in half, we get a negative 3. Square it, we get a 9. Okay. Now to the right-hand side, we have to keep in mind the GCF that we pulled out front. So 9 times 9 is 81 that we're adding to the right-hand side. Okay, and then for our y's, our b term is a 10. Cut that in half, we get a 5. 5 squared is 25. So then to balance it out, remember the 4 that we pulled out. So 4 times 25 means we're adding 100 to the right-hand side. All right, guys, so now just go ahead and factor and simplify. So we're going to get 9 times x minus 3 quantity squared plus 4 times y plus 5 quantity squared. And then if we add up our right-hand side, we get 144. Okay, now there's one last step we have to do in order to put this in standard form, and that is to make sure we get a 1 on the right-hand side. So in order to get a 1 on the right-hand side, we're going to divide everything through by 144 and simplify. Okay. All right, so starting off with our x's, 9 divided by 144 is 1/16. So that's going to be x minus 3 quantity squared over 16. With our y's, 4 divided by 144 is 1/36. So that's going to be y plus 5 quantity squared divided by 36. And that is now equal to 1. Okay. All right, and then once we get it in standard form, then you're just going to go through the process like we've done with all the others, figure out whether your major axis is horizontal or vertical, find your center, your vertices, your minor axis points, and your foci. So I'll leave the rest of the problem to you guys, but the full solutions are posted on Blackboard. Okay. All right, I think we're going to end this video here, and we will do one more quick video with a couple more examples.